In the remainder portion of your syllabus, there are a lot of patterns that get asked. The most easily identified out of these is the general remainder format. And what do I mean by that? Some number a to the power, let's say 1001 divided by b. And they simply ask you what is the remainder when you will, when you will do this division. Now, the approach for us in this particular question is very clear. There is only one approach. We don't need any fancy formulas for this. We will try and make one as soon as we can. The idea being that any operation that is happening, you know, here, you can extrapolate that to only the remainders itself. So if let's say I get that a cube leaves a remainder of 1 when divided by b, I can write this a to the power 1001 as a to the power 999 into a square divided by b. And I know that since a cube leaves a remainder of 1, I will further write this as a cube raised to the power 333 into a square by b, and then I will say that a cube leaves a remainder of 1. So my final answer will be 1 to the power 333 into a square by b. Whatever remainder comes from here, that multiplied with 1 to the power 333. This is my standard go-to approach. So this observation that a cube will leave a remainder of 1 when divided by b, this is something you have to keep an eye out for. This may be readily apparent or this may not be readily apparent. The answer here will be, I hope you appreciate that calculating what a to the power 1001 will be, it's a tedious task. You can't do that even if a is 2. But calculating what a square is, that is something you can definitely do. And then you can divide it by b and get your remainder. So this is one of those examples where you are able to identify what is happening within one iteration itself. You were able to directly identify by looking at a cube that boss a cube leaves a remainder of 1, so I will use that. What if the question requires a second iteration? That will look something like this. So let's say a cube leaves a remainder of c, and this is something you identified. Now what is one of the reason why I would stop at a cube or a square? Maybe if I go till a to the power 5, I will find my remainder of 1 that I'm looking for. So what is one of the reasons from a practical standpoint that you will stop at a cube? The reason would be, just the effort that goes into it. Would calculating the fifth power of 13 be something that you will prefer in the exam? No, right? So I will use a cube that gives me a number c, then I will deal with c to the power 333 into a square divided by b. And maybe c divided by b leaves a certain remainder that I can deal with. For example, maybe c square leaves a remainder of 1, which makes my calculations easy because now I will write this as c to the power 332 into c into a square divided by b. Now I know that when I write this c to the power 332 as c square to the power something, c square will leave a remainder of 1 and 1 to the power anything will be 1. So my final answer will be c into a square divided by b, whatever the remainder will come from here. So this required a second iteration. We relied on this intermediate term c to get to our answer. Hypothetically, you can directly get your answer, but it could maybe, go till a to the power 9. In which case, on paper it looks good, but it is not feasible in the exam. Now, in your attempt to identify this c, you should leverage both the remainders, the positive one or negative one. So if you remember, 4 when divided by 3 leaves a remainder of 1 which is positive, or you could also say that it leaves a remainder of minus 2 when divided by 3. So the trick being the positive remainder minus the divisor is equal to the negative remainder. So you can leverage your negative remainder as well. We look favorably upon one. Our whole agenda is to get one ASAP in the remainder or minus one. We don't have any preference between these two. Both of these will work just fine for the simple reason that these two numbers raised to any given power can be very easily calculated, which was the whole idea behind getting 1 or minus 1. Reduce the magnitude to something which will never change. All right. So far everyone is clear. I hope this is something we have seen a lot. What if the divisor and the dividend, the numerator and the denominator have a factor in common? What if this was something like b into a to the power 1001 divided by b square? So this is the next level of this question. Just dressing the question in a different way to get people to commit a mistake. So what most people will do is cancel b with b. They will say that this is the question that I have to deal with. They will find the remainder for this. Let's say the remainder for this is r, and they will mark r as the answer. But that is incorrect. What you have essentially done is we took b common, then we did our remainder calculations for a to the power 1001 divided by b. Whatever this answer came out to be, I would multiply that with b. Let's say this is r, and then divide this answer with b square to get my final answer. So I will divide this with b square because b square was my original denominator. So I will retain that when I'm calculating my final answer. So if I were to make a flow of this, I am given b a to the power 1001 divided by b square. I will detach the b, convert the question to a to the power 1001 by b. I will get the answer for this as r. By detaching this b, what I had essentially done was taken it away from the numerator and from the denominator. So I will multiply it back to the numerator and also to the denominator, which was already b. So this will be b square. So your answer will be r into b. Whatever this number comes out to be, you will calculate that and then divide it with b square. Are we clear on this? Can we move ahead? The remainder situation can also be asked in numerous ways. Uh, there is a whole set of rules, divisibility rules that we will quickly go through for the most important numbers that you should probably know. It will help you to factorize, it will help you to eliminate options. Your divisibility rule for 2, 3, 4, 5, 6. 7 is not that important, 8, 9 is very important, 3 is very important. So all of these we'll quickly see. Apart from this, we also get a situation where we are given that a number a divides b. Now in yesterday's class we saw that this means that a is a factor of b, or I can write b is equal to ak. What we have really done here is written this, that a into k plus a remainder of 0 gives me b. So this is essentially this factor statement, and we'll quickly look at an example very soon. This is the intersection of the factor concept and the remainder concept. For someone to be a factor of something, they should leave a remainder of 0. The third type of question that you can get in remainder is word problems. They will say that a class has these many people, and if you divide them in groups of 9, you will be left with 3 students. So when I say that, what I'm really saying is that the total strength of the class is 9 into k plus 3. If I'm dividing them into groups of 9, 3 will be left. What does it mean when I say 3 will be left? I'm simply saying that the remainder will be 3 when I divide them into groups of 9. So they would, try and give you multiple statements like this, that if you divide them into groups of 9, you will get a remainder of 3. If you divide them into groups of 5, you will get a remainder of 2, and so on. So we will have to make statements like these and move on. This usually leverages your HCF and LCM concepts. Within this situation, there are two types of questions that you can get. All right. And now listen carefully. One situation is they say that dividing them into groups of 9 leaves 3 people, and dividing them into groups of 7 leaves 2 people. The other situation is they say when you divide them into groups of 9, you get 3 people remaining. And also, when you divide them into groups of 7, you will still have 3 people remaining. What is it that has changed in these two situations? The remainder has changed. So, this situation we will tackle in a few moments. This one is very easy. If a number when divided by 9 leaves a remainder of 3, and when divided by 7 also leaves a remainder of 3, can I say that the number will be of the form LCM of 9 and 7 into some constant, let's say q, plus 3? Because when I divide this with 9, this term will get cancelled out by 9, so the remainder here will be 0 and your final remainder will be 3. If I do this division with 7, LCM of 9 and 7 will be divisible by 7, so this entire term will give you a remainder of 0 and you will be still left with a remainder of 3. So this particular situation, when getting divided by two different numbers leaving the same remainder, this uses LCM to get a solution. The other situation we will see, it's a bit more difficult and lengthier, but there is no other workaround for that. So let's move ahead. Let's look at one more situation. What about the fractional situation? Now, this is something which, I don't think anyone teaches. What if I give you a statement like this? 1 by A plus 1 by B is equal to 1 by M, where A and B are natural numbers, M is also a natural number. How many possible values of A and B can you find? Now, the method for this is something which will use remainder, in a very creative way. What I'll do is I will separate these two, A and B that I have to find. I'll say 1 by A is equal to 1 by M minus 1 by B. What I will then do is I'll get A is equal to M into B divided by B minus M. After this, I will convert this expression. I will extract some constant out of this. I will write this as MB minus M square plus M square divided by B minus M. This will give me M times B minus M divided by B minus M plus M square by B minus M. This B minus M and B minus M will cancel and I will be left with M plus M square by B minus M. This is the value of A. Now A is an integer and M is also an integer, which means what? That M square by B minus M also has to be an integer, which means B minus M should divide M square. And now it will be very easy to find the values of B because M is something they will give you. For example, if M is given as 25, sorry, 5. So you want 5 square by B minus 5 to be an integer, which means B minus 5 has to be a factor of 5 square. What are the factors of 5 square? 25, 5 and 1. So you can equate it once to 25, you can equate it once to 5 and you can equate it once to 1. Corresponding to this, you will get values of B, and corresponding to those values of B, you will get corresponding values of A. So the negative I am removing here, negative values B minus 5 is equal to minus 25, B minus 5 is equal to minus 5. That would also be allowed in this particular situation. However, for now I am working on the assumption B is greater than equal to A. All right, which would necessitate that B minus 5 is greater than 0. All right, so we will see an example soon for this. So this fractional thing, if this question comes and if you don't know how to do this, that this is the exact method to do this, you will be stuck. You will end up trying a lot of values of A and B. You'll waste a lot of time on hit and trial. In fact, most websites and your coaching institutions, when they provide solution for this, they encourage hit and trial, which I hope you understand is going to be a difficult task. For example, if M was equal to 9, B is equal to 90 would have been a solution. So can you hit and try till 90? You cannot. All right. So the question states that the total number that is given to you, t is equal to 7p plus 3 divided by 7 leaves a remainder of 3, which is equal to 5q plus 1, which is equal to 6r plus 5. All these three statements are telling you information about this total number only. So can I equate them to each other? Can I equate 7 plus 7p plus 3 to 5q plus 1 to 6r plus s? So then I will do this. I will pick one of those randomly. I will do that. I will, let's say, take 6r plus 5. And first I will equate this to this. I will get 7p plus 3 is equal to 6r plus 5, which will give me p is equal to 6r plus 2 divided by 7. Now, p has to be an integer, which means 6r plus 2 has to be divisible by 7. Remainder should be 0. So let us equate the remainders. 6 by 7 will leave a remainder of minus 1. This minus 1 into remainder of r by 7 plus remainder of 2 by 7, which would be 2, should be equal to what? 0. Which means that the remainder you get when you divide r by 7 should be what, so that you get 0 as an answer in this particular equation. Everyone, it should be 2, which means r leaves a remainder of 2 when divided by 7, or r becomes 7 some random number s plus 2. Can I say r is 7s plus 2? This will be the general form of r, 7s plus 2. Now I will do this again with the other numbers that I had. 5q plus 1 is equal to 6r plus s, 6r plus 5. This will give me q is equal to 6r plus 4 divided by 5. Now again I will do this. 6 by 5 will leave a remainder of 1 into the remainder when r is divided by 5 plus 4 is equal to 0. What should be the value of r here? It should be minus 4, or I can call it 1 also. It should be minus 4, or I can call it 1. Because 1 into 1 plus 4 will give me 5, and 5 remainder when divided by 5 means what? A remainder of 0. So you can get the negative remainder. You will say that this remainder should be minus 4. What does a negative remainder of minus 4 correspond to? A positive remainder of 1 when you are dividing by 5. Yes. Which would mean that this number r is of the form 5t plus 1. Now I will equate these two. 7s plus 2 is equal to 5t plus 1. I will get 7s plus 1 is equal to 5t. And from here, using hit and trial, I can find, the values of s and t. So 7s plus 2 will turn out to be 16, which is the value of r. This is 16. And which, when I put in 6r plus s, I will get the value of t, which is 16 into 6 plus 5, which is 101. Now, obviously, all of this hustle we will do only if it's not a, you know, uh, if it's a theta question. If the options are given and they are like these, then might as well divide by 7, 5, and 6 to get your answer. I mean, this leaves a remainder of 3 when divided by 5. So, can't be your answer. This leaves a remainder of 2 when divided by 5. Can't be your answer. This leaves a remainder of 4 when divided by 5. Can't be your answer. Just by using this statement, we are able to get your answer. Right? So, this was a bad question because of the options. But if it was asked in theta, this is something we would have had to do. Now, realize that if only two data points were given, if you only had to satisfy two results here and not three, you would have directly got to this step, which would have been pretty easy to do. This exact same step you can do earlier also. When you got r is equal to 7s plus 2, you can guess the values of r. From here itself, you will say r is equal to 9, r is equal to 16, and for that r you can check if you're getting integer q. S and T can be more combinations. Yeah, you can get more combinations, that is correct, but they are asking us for the smallest three digit numbers. So the other combinations will correspond to the next number which will satisfy this result. So these sort of result would not be satisfied by only one unique number. These can be satisfied by a lot of numbers. Yeah. So the second trick here which Harsha has done is, so Harsha was able to observe. So what I have described is the standard approach for this, if nothing works, and if you are not given options. So this was 7, you know, p plus 3 and 5q plus 1. Can I write this as 7p minus 4 and 5q minus 4? Which would mean that the remainder, when I write it in negative, is same. So the number would be of the form 35k minus 4. Because when you divide this by 7, you'll get minus 4 as your remainder, which is what we wanted. And if you divide this by 5, you will still get minus 4 as your remainder. You know, first, if it's an option based question, use the options. You will be much more faster. If options are not given, if it's a theta question, then you should observe the positive remainders, convert them to the negative remainders, and see if they are equal for one pair. If they are, you can reduce the calculation for that by using the LCM method. If this is also not happening and options are also not given, then you can either leave this question because it will be lengthy, or you can follow the approach that we just discussed. All of this keeping in mind that if three data points are given, then this is the process that we will follow. If two data points are given, it's going to be a very easy question regardless. You might even be able to guess the number. Chalo, I will just make a diagram for you. There were three remainder results given to you. We use these two to get one equation. We used these two to get another equation. Then we equated these two and found our answer. यहाँ पे we did hit and trial. What Harsha did was, you have R1, you have R2, you have R3. He directly observed that R1, R2 can be clubbed into 35k minus 4. So essentially, instead of having three remainder results, he said that there are actually two remainder results only, this one and this one. So then he clubbed these two and then directly applied hit and trial. So instead of a three level question, he was able to convert it into a two level question by hit and trial. And this R1, R2 to R4, this uses your LCM thing that we have previously discussed. I hope this is much more clear now. All right, moving on to the recurring digits part. Now, these sort of questions would generally be asked when your denominator is of the form 10 to the some power plus minus 1. So it would either be 99, 101, 999, 1001, and so on. In these situations, what we actually have to do is first observe the denominator. If it is 99, I will break the number in the numerator into blocks of 2. What is the numerator's general form? I am talking about recurring digits, so digits would be repeating. So if I take an example, let us say that you are getting 78 to 1, 7821, 7821, 7821. This four blocks are repeating, let's say, for 100 times. Now you can't really do this division, 7821, 7821 divided by 100 times, 99 divided by 99. What we can instead do is, we will write this as, I will go towards the end. I have seen that this is 99, which means I have to break it into blocks of 2, packets of 2. So this 7821 I'll break as 78 and 21. This will be written as what? 78 into 100 plus 21. Now, what will be the remainder when 21 is divided by 99? 21. What will be the remainder when 78 is divided by 99? Minus 21. And what is the remainder when 100 is divided by 99? 1. The next number that we will have is 21 into 100 into 100. So 100 square. This will leave a remainder of 21. 100 square into 100, 100 into 100 will leave a remainder of 1 into 1. So still 21 into 1. The next number before this would have been 78 into 10 to the power 6, which is 100 cube. 78 into 100 cube. What is the remainder when 78 is divided by 99? It is minus 21. What is the remainder when 100 is divided by 1? Sorry, 99? 1. So this would be 1 cube. So can you see that the remainders are actually 21 plus minus 21 plus 21 plus minus 21. So I can see that an entire block of 4 is giving me 0 as a remainder. So actually this entire number, which has 100 such blocks, each 4 block, is giving me 0 as a remainder. So final remainder will be 100 into 0, which is 0. So if I were to make the flow for this, first observe the denominator. Based on that, divide the numerator into packets. Calculate remainder for the packets till you observe a pattern. After that, just directly find the sum. Once you observe the pattern, directly find the sum. So I just pulled this question out of thin air. And my idea was simple. I wanted to get 0 as a remainder, so I took 99 as the denominator. I fixed the first one as 78, and I fixed the other one as minus of that when you are dividing by 99. So 78 plus 21 will give you 99. So I hope clear on this. This is highly, highly unlikely to come. People do ask this in mocks, but I mean, if you look at actual CAT questions, you will be, you know, uh, we will be shocked if something like this comes in CAT exam. All right. Now, this trick will only work if your denominator is of the form 99, 101, 999, 1001. If it is not of that format, then we will have to think of something else. And that something else would be the divisibility rules for specific numbers, which we will shortly see. First of all, the family of 2. Division by 2, the last digit must be divisible by 2. By 4, last 2 digits. By 8, last 3 digit. By 16, last 16 digits. In general, the divisibility rule for 2 to the power n is last n digits should be divisible by 2 to the power n. Family of 3. Sum of digits must be divisible by 3 if you want the number to be divisible by 3, and same for 9. If the sum of the digits is divisible by 9, then the number itself is divisible by 9. Family of 5. Last digit must be 5 or 0 to be divisible by 5. If you want to be divisible by 10, last digit must be 0. If you want to be divisible by 100, you want the last two digits to be 0. Yeah, same for 27 and 81 and so on. Correct. Uh, 27, I'm not sure. I think you will have to check for, but I think that is correct because the proof for this is very straightforward. It relies on the fact that 3, 3 square, 3 cube, it works on these. So it should be true. You can check. All right. 11. The alternate digits sum, the difference of those should either be 0 or a multiple of 11. If that is true, then the number is divisible by 11. This is, us stretching our memorization to extreme. You should not go and memorize for 7 and 13. You don't really need to do that. There are longer rules for this, but it is inefficient. For composite divisions, what you should try to do is you should break the number into co-primes for which you know the divisibility. Then you should check the divisibility for individual co-primes. And this should be true for all the co-primes that you have taken, which is something we do here, right? If I want a number to be divisible by 12, what do I do? I check divisibility by 4 and I check divisible by 3, and I say that these two should be true at the same time. If I'm checking for divisibility by 6, I will check for 2 and 3. For 18, I'll check with 2 and 9. All right, are we clear on this? All of this? All right, so let's move to the digits part. Now, most questions in digits would be of the format of a word problem where they say this digit is exchanged, this digit is written incorrectly. So what you should be knowing in that particular situation is how to write a number if the digits are given. So a number is represented as, you know uh, a plus 10b plus 100c plus basically 10 to the power n into the number in digit in that position. All right, so 1023 is actually 3 plus 2 into 10 plus 0 into 100 plus 1 into 1000. This expansion gets used quite a lot. Now, all of us know unit digits have cyclicity. After a certain power, the unit digit starts to repeat. So, for 1, that is going to be a cycle of 1 only. If your unit digit is 1, doesn't matter what the number is, 31 to the any power, your unit digit will be 1. For the rest, the cycles are given as shown. The fact is, you don't really need to memorize this cycle. You just need to know that for unit digit, the max cycle will be 4. It would be something you can immediately calculate based on what the question has given you. So you should not be committing this to memory that 7931. I mean, how difficult it is that 7, then 7 square is 49, then 9, then 7 cube is 343. So 3, and then 3 into 7 is 21. Now once I get 1, next will be 7. So you don't need to memorize this. Last two digits is something that you should probably memorize. So if the number is of this format, that the last digit is 1, your powers will increase by a. Your second last digit will increase by a. Unit digit will still remain 1. Your second last digit will increase by a. So if let's say this is 31 to some power, the cycle will go as 31, 61, 91. The 91, if you add 3, will give you 121. So then 21, 51, 81, 81 plus, if you add 3 here, 8 plus 3 is 11. So this will give you 1. 1 goes away. We are not concerned about the third digit. Then you will have 3, you will add 2, 1, that is 41. Then you will get 71, and then you will finally get 0, 1 to 31. So it will repeat like this. So this number, the second last digit, gets increased by itself every time. For 25, it's always going to be 25. 25 square, 625, and so on. It's going to continue. For 24, 76, and 74, it will oscillate. You can check, but the oscillation is between 24 and 76. So even power 76, odd powers 24. So you can commit that to your memory. 76 always. So this is an exception like 25. For 74, first power will be 74. You will get 76. Then you will get 24. Then you will get 76. Then you will get 24, and so on. Yes. So these are the few numbers that you can, again commit to your memory. Highly unlikely cat will go to this level, last two digits. They can go for the unit digits. It is very, easy to be done in a 2-minute time frame, but last two digits is highly unlikely. All right, moving on. Highest power in factorial. Now, you might come across situations like 120 factorial. What is the highest power of 5 in 120 factorial? So, the method for this is clear. We will divide 120 by 5. This will give you 24. So, I'll write 24 here, I'll write 24 here. When 24 is divided by 5, the quotient will be 4. So I'll write 4 here. When 4 is divided by 5, the quotient is what? 0. So I will need not continue after this. So the number of, the powers of 5 in 120 factorial will be 28. If this was 3, I will do 120 by 3, 40. 40 by 3 will give me 13. 13 by 3 will give me 4, and 4 by 3 will give me 1. After that, I need not check. So your number of powers of 3 in 120 factorial will be 40 plus 13 plus 4 plus 1. Now, yeah, you can also think of it as 120 by 5 plus 120 by 5 square plus 120 by 5 cube, and so on. It's up to you how you guys want to go ahead. Now, couple things of note. Number one is number of zeros at the end is determined by the number of tens present in the factorial, and that depends on powers of 2 and 5. Now, when we do this discussion, because 10 is made up of 1, 2 versus 1, 5, you can directly check the numbers of 2s and 5s and get your answer. Now, obviously, the number of 2s would be much higher for any factorial than 5, which means the only thing that you need to check for is the powers of 5. You don't really need to waste time checking for powers of 2. What if this situation was asking for 12? Now, 12 is made up of 2 square into 3. Now, technically, the number of powers of 2 in any factorial would be more than number of powers of 3. 2 will outnumber, but for every one 3, two twos are getting consumed. So the ratio should be greater than 2, in which situation you should probably find both of these, the powers of 2 and the powers of 3. So if the powers of 2 comes out to be 57, I'm just randomly pulling number, and power of 3 turns out to be 24, what is the maximum power of 12 that you will get? In this situation, who is the limiting factor? 24 threes would have consumed 48 twos. So the powers of 12 would be 24 itself. What if this was 57 and 30? Who would have been the limiting factor in this situation? Now you have 2 to the power 57 and you have 3 to the power 30. Each group of 2 will consume 1 3. So 2 to the power 56 will consume 3 to the power 28, after which you will be left with this one standalone 2, which will not, uh, be able to give you a 12. So your answer for this situation would have been 28. So checking the limiting factor is highly advised.